if w equal to fz equal to u plus iota v and u minus v is e the power x cos y minus sin y, we need to find the value of w in terms of z. So this is the example of Cauchy Riemann equations. So this is given to us, right? Okay. Let's derivate this with respect to x and y. Let's first derivate this with respect to x. So this is del u by del x minus del v by del x equal to the first function into the derivative of second with respect to x, that is 0 because it is in y, plus second function and the derivative of first, that is e the power x. So this is equal to e the power x into cos y minus sin of y, and now derivating this with respect to y. So this is del u by del y minus del v by del y, that is equal to the first function derivating the second with respect to y. This is minus sin y minus cos of y, plus writing the second function and the derivative of first with respect to y, that is 0. So this is equal to negative of e the power x sin y plus cos y, but I am writing here cos y plus sin y to have this format. Please mark this as 1 and this as 2. And now I am going to use the Cauchy Riemann equations. What are those? So these are del u by del x equal to del v by del y and del u by del y equals to negative of del v by del x. So these are the two Cauchy Riemann equations. How to use them? I'm having here del u by del x minus del v by del x. And here I'm having del u by del y minus del v by del y. Now from the Cauchy's Riemann equation I know that del u by del y is minus del v by del x. So I can write in place of this as negative of del v by del x. And del v by del y is del u by del x. So I can use here del v by del y as del u by del x. So let's write this. From 2 we get, writing del u by del y as minus del v by del x and del v by del y as del u by del x. So this is minus del u by del x, that is equal to the right hand side, that is minus e the power x into cos y plus sin y. And from 1 we get, okay, in the bracket I am writing, using Cauchy's Riemann equation. See our equations. So marking this as 3. And from 1 we are having, just write same as it is. Managing these signs, we can write the left hand side as negative of sum of these two and cancelling this sign with this sign. So from third equation and this first equation, I'm having del u by del x and also del v by del x. Just add these two together, we get. So when adding the left hand side, we get twice of del u by del x equal to, on the right hand side when we add, we get twice of e the power x cos y. Cancelling this 2. So from here we get del u by del x to be equal to e the power x cos of y. Similarly, if I subtract third and 1, we get, so from the left hand side we get twice of del v by del x on subtracting. And on the right hand side we get, when subtracting, we get twice of e the power x sin y. So twice of e the power x sin of y, cancelling this 2, and we are getting del v by del x to be equal to e the power x sin of y. Very fine? Yes? We need to get what? We need to find w equal to f of z, that is equal to u plus iota v in terms of z. Yes? One thing we know that f dash z equals to del u by del x plus iota del v by del x. Please remember this result, it is very important. So solving this we get, what is del u by del x? It is e the power x cos y plus iota, what is del v by del x? It is e the power x sin y. So this is your f dash z. To find f of z, by Milne's Thomson method, we always put x equal to z and y equal to 0 in f dash z. Yes, so writing this, using Milne's Thomson method, replace x with z and replace y with 0 in f dash z. Okay, replacing x with z, it is e the power z and cos of 0. Y is replaced with 0. So cos of 0 is 1. So we are getting e the power z plus iota, again e the power z into sine of 0 is 0. So it is 0. So this is e the power z only. F dash z is e the power z only. Okay, integrating this with respect to z, we get f of z to be equal to e the power z plus the constant. And what is f of z? It is w, right? So we have found the value of w in terms of z. In terms of z. So this is the required answer. Okay, thank you. Stay blessed.